Hello everyone. Hi. This is VLSI updates and myself Prashant. And I just thought of having these discussions, and we have created this VLSI updates group, and we have the blog, and we are creating this VLSI YouTube channel. So the idea of creating this channel is to provide the information and about VLSI or different opportunities available in VLSI and to gain the freshers and even for experienced candidates who seeks for more knowledge and to learn continuously. So and also I would like to add more support to the VLSI aspirants who is interested in seeking knowledge in VLSI domain, and there are a lot of questions about where to begin with and how to begin with and what to do and which one to choose, design or verification or the validation or the APG, ASIC, emulation, physical design, analog layout. So there are a lot of questions, and so um, I thought it would be interesting, if you know some low-level informations and what happens in each domain and what are the skill sets are primarily used and how I'm going to build my career in each in this VLSI domain and which one to choose and how can I keep going forward for that. So I just thought of sharing a quick session on that, and so based on few questions from the LinkedIn post and my interaction with the few freshers, and also I came up with some kind of block diagram and which I'm currently presenting to you all. And this is we have this VLSI, the flow diagram here, and if you see here, and we have this. There are two, branches, which is called the front end and the back end. So as we all aware, like the front end is something like we do design and the verification, and in the back end is something like we have the physical design environment, and we do the analog layout in the chip level, and that is the major division in that. Okay, so the basic skill set to enter into any of these domains, let's say front end or the back end. Okay, you must be having some kind of idea. Let's say you are good at the digital design skill set, and you are you have some experience with the hardware description language, Verilog or VHDL, and you started practicing yourself in the APG area, and you started learning system Verilog language, and you started coding using script, TCL or Python scripting and all. So these are the good skills to have to consider to be in the front end domain. And in other side, the back end is something expect you to have more understanding in the transistor level. Here you should have a more circuit level understanding. Okay, how do you design circuit using CMOS transistor, which is the underlying technology of any chip architecture. So we are seeing a lot of updates in terms of the nanometer technology improvement, and currently we are into up to 2 nanometers. We are be discussing, and we started with 180 nanometer and 90 nanometer, 60 nanometer, and the technology is keep shrinking. So what happens when the technology keeps shrinking? The challenges increases in the industry, VLSI industry, not only in terms of the front end design, in order to fit into that smaller environment and the larger design, do the fitting analysis, timing analysis, and a lot of issues, right? You can see like you're trying to fit, uh, you know, 10 times of transistors compared to last decade, and you're trying to fit them into the smaller area, and you need to have the technology for that, like because humans cannot do all this stuff, right? So we have to rely on the tools most of the time for that. So in the back end, the challenge mostly could be in the tool wise, right? So we have to be like very well aware of the tool flows and how to use them, how to get the issues, and how to fix them, you know. So you need to be more analytical person, and so for that, that's what CMOS understanding. Of course, we need to have some hardware description understanding as well. And scripting is important. Why scripting is important? Because when you do the activities, the pin mapping, pin planning, um, if it is smaller design, you can do that by own. And what if it is a larger design? You have the thousands and thousands of pins. You have to map it to the particular ports, and in that case, you can use the scripting flow and just write the script, and through script try to automate this kind of manual work. That is the reason scriptings are important, and timing analysis is essential in the physical design flow, because so once a design is ready, that's a design engineer, they do the functional simulation, and they see the design is working fine. When it comes to the physical design, you see the real-time cells. You apply the cells, you apply the real timing parameters, and use that design to see whether the design is meeting the timing requirement or not. And if you can modify the standard cells, the characteristics, you can do it by your own, or you have to get back to design team and give the feedback to them that I'm observing this particular design is not meeting my timing requirement. Can you go back and look into your design and fix it? So that kind of the loop back work has to happen in order to fix that timing issues. And so in terms of analog layout, and it's more into the circuit level work. We use some tools to draw this layout and all, and it will be like purely like the CMOS way, and we have to do that handcrafting things. We have to do that work. So again, yeah, it will be like SOC level. And you'll be working on any particular block, and you'll be handling those particular block, doing the analysis like power analysis, and uh, wire delays, resistance. So yeah, this is an interesting area to work on. And this other part is coming called simulation acceleration, which is called pre-silicon validation. Why we call them as a pre-silicon validation? So going to silicon is really costly, and uh, why it is really costly? Because it has to go through the entire fabrication process, and uh, if you are going for a smaller volume of manufacturing, then you're going to lose a lot of money in that. So this ASIC, um, this fabrication process are preferred for the ASIC design flow, where there are larger volume of manufacturing, and they can go for this ASIC fabrication process. So in that case, when they're going for the millions of chips, and so they have to spend a lot of infrastructure, and they need to have this kind of pre-silicon environment before they actually go into the silicon manufacturing. How it helps, right? So we have the simulation, and we do the simulation for the design, and we verify the functionality, and uh, uh, and we are confident that my design is fine, and we are going to work on it, right? So that's the confidence basically we get. But what happens ultimately? Um, ultimately what happens, we need to 100% sure that my design works in the hardware. Of course, if the design works in simulation, it has to work in the hardware as well. So then why do we need this exactly? So let's say I have a design, a little complex design. So I'm going to run it through the simulation. It has to go through the thousands of iterations and get me back with the results. So I see it's consuming time almost um, months, and even some complex signal processing application consumes like years. We don't know when it will complete. So that kind of situations are exist in the present scenarios. So considering the timing, considering the chip to the market availability, right? So this infrastructure is being built to save the time. It's not like we are going to replace the simulation verification with our hardware verification. We are not going to do that, and that's not our goal. And here we are going to accelerate the simulation verification. We are going to run the test cases. We are going to verify the chip uh, in very shorter time, very shorter period. That's a primary goal of having these things. And we have the emulation platform, we have the prototyping platform, we have the virtual prototyping platform. So this is called pre-silicon validation environment. Any chip in manufacturing, any chip industry must have this infrastructure before they go to the actual silicon environment. Okay, so we'll come back maybe to understand the significance of these in more detail so that it will be very clear to all of you. And we have this post-silicon bring up. Once the chip is available, there should be a team to work on that and to work with the software and the embedded software and the hardware and do all the if you are building a chip mobile processor, you need to check the OS booting and run the software applications and see everything is functioning as expected, right? So there will be a post-silicon bring-up team to release the chip finally to the customers. So that's the overall idea here. So now let me come to your concerns, like which one to choose, whether I need to go for a design or verification or a physical designs or analog layout or the pre-silicon validation or the post-silicon validation, which has more scope in terms of money, in terms of learning, in terms of career growth, right? So there are a lot of questions about all these things and how it is going to help the people in understanding all these things. So so again, you can develop any of the skills at any point of time, and you can learn the digital design. You can practice your hardware description language. You can spend time in understanding the PG architecture and you can work on the system Verilog and the UV methodologies, and you can develop any skill set you wanted, and then you can choose to go to the domain you like it exactly. So when it comes to the domain selection, and we have you know in the front end domain we have the design and verification, and it depends on your interest as well, right? So it's not about always the skill set. If you are good at digital design, and if you're thinking logically, your logical thinking is good, and you feel like enjoying that work, and you wanted to think more technical terms and analyze more about the design and how does this work, and so it depends on your interest, right? Skill sets, of course, skill sets are important, and you can gain them by spending time and practicing them. You can gain those skill set, right? But ultimately, um, the job demands your logical thinking and analysis skill set, and how do you approach a design, how do you take it forward, right? So these all are important. If you don't like your the work you're doing, so there is no point in having the skill set, relevant skill set, and you don't know how to apply those skill set, right? So when you feel interested, like when you start applying your skill set and seeing how this is impacting my work, so how I'm going to realize my understanding, right? That's where actual the interesting job comes. So again, I would say you can learn the skill set, you can explore initial time. Let's say you're junior, you get some chance to work on some front end or the back end area. Just let us explore. Let us not decide I want to be a back end engineer, I want to be a front end engineer, I want to be emulation engineer. Let us not decide it. Let us explore and let's find out and which is my interest, right? Is it keeping me excited or not? So how am I going to do this work? Will I be enjoying this work or not? So you can explore the different options till 2 years, 3 years. You can explore the front end area and the back end area, understand what design engineers does and what the physical design engineer does, and which one I want to go for now. Then you choose. Like after once you have the enough skill set, you can choose to change your domain wherever the domain you want, and you can start building your understanding on top of that, and that's how the career moves, right? So be open to learn. Don't limit yourself that I'm a front end engineer at the early stage. It's not decided, right? You explore it and then you decide that I want to go for a front end. Yes, I am interested in design. I mean, I can do better in verification. Yes, let me go to the verification. I can do the plan. I know the design. I can do the test plan. I can create a test bench, right? So you can go in that areas. Okay. Um, yeah. So the point I wanted to cover here is a design domain. Yes, of course, we have the ASIC and APG, and the verification area. We can do the verification for the SOC level and the block level. And physical design, as we said already, we have the timing analysis and we have to do the physical synthesis. And analog domain, we have the analog and digital domains and emulation platform in the pre-silicon validation and post-silicon bring up. So these are the overall ideas. Apart from that, we have some protocols to be learned. You can choose to work on any specific IP. Let's say you're interested in the PCI. Let a lot of updates and there are a lot of technology development in the PCI side. Okay, you can and it's keep increasing because of the demand. It's the only way of communication to any chip and uh, to transfer the data and which is very essential part of any chip. So you can be in the hardcore of development of PCI and working on the DDR. We have the LP DDR, it's for the mobile, and the DDR, GDDR for the graphics, and DDR for the um, for the other processes. So we have these varieties, and we have the CXL, NVMe. So these are the different technologies. Okay, so when you have the basic skill set, I can develop a good test bench. I can write a good test cases. I can do the best coverage. I can do the best assertions. I can do the best debugging things in the ground, right? So you can take up this hardcore challenge, and that is when actual technology changes you can observe, right? So what is the difference? Like when we change the SOC, what we are changing, we are not going to change the entire design here, right? We are going to update the future of it. We are going to change the technology. We are going to change the IP technology, or we are going to change my connections, like the USB version change and CXL is latest technology change. So that's what happened. We are not going to rebuild the entire SOC from the scratch. That's not going to happen. We are going to upgrade ourselves and we are going to work on it. So it's important to put us into that hardcore technology area where we can stay connected with the technology and learn those things and be a challenging in the environment. And so that's what is going to make us more interesting into the VLSI domain, right? So which is very important, of course. right? So on the other hand, how the APG helps, of course, APG is accelerating the hardware activities, and without that we cannot realize, you know like we cannot always go for the ASIC. It's very costly, as I said. We cannot always expect any smaller design or the smaller IP or smaller custom design. We cannot directly go for the ASIC. It's very costly, and so APG provides a flexibility that you can come to my platform. You can verify your design on me, and if it works on me, you can take it to the real hardware. Right? That's what the actual pre-silicon validation does, which is for the bigger designs for the SOCs and all, right? So for SOCs, it will be having the billions of gates, billions of logic gates. We cannot fit into the one or two FPGAs. That's what the emulation platform comes, which will have multiple number of FPGAs interconnected together, and how they are connected, right? So and you can place your design over there, and you can do the verification. I mean, hardware verification, right? So it will be done in hours, which will be running in simulation for days and days. It saves a lot of time, right? So it like the initial effort is to create that infrastructure. Once the infrastructure is up, we can put any design onto an emulation platform, and do the validation and do the verification, hardware verification, right? So that FPG brings up, right? You can develop your smaller designs, like which will have millions of gates. I don't want to go and spend time in the pre-silicon validation platform. Let me go to my FPGA board. I have the hardware board there, so I can put my ASIC design into my FPGA. I can I can put my ASIC design into my FPGA, and I can start seeing what's happening. So that I can do, and that's a easy way to do as well, right? So yeah, having a knowledge on FPGA and working on the real hardware gives a different experience in that case. And ultimately, you're going to accelerate your custom design into the real silicon. So that's the reason most of those companies prefers FPGA for smaller designs, and for bigger SoCs, of course, they have to go to the emulation platform. That happens. Verification won't change, and you always keep the methodology for the IPs and the SOCs, and you work on it. And hardware engineers different, right? So that's how things happens in the industry point of view. And um, apart from that, we'll be having different protocols. But being in the entry level, what your primary focus should be like. Uh, to get into any of the VLSI domain, and start learning and start understanding things, start building knowledge, right? So skill set, you can always build your skill set, right? And but knowledge comes when you spend, when you apply your skills and in the real time, and understand things. Okay, so that's where the knowledge comes. And so you have to focus on learning initial time, and explore different areas. And before you choose, I want to be the front end or the back end engineer, you have to experiment yourself a lot, and choose which one to go for, right? So that would give you the longer career standpoint of view. And I have been hearing a lot of questions, and regarding the college, which college I'm coming from, whether I will get an opportunity into the VLSI domain or not. And there are a lot of questions, and but yeah, if you're trying to enter into that, if you keep practicing your skill set, you can definitely enter into any of the VLSI oriented industry. And if you have any dream companies, like product companies, of course, you can work very hard to get into that. And once you have enough confidence and the skill set and the knowledge, of course, you can try and crack that opportunity. That you can definitely do it. And apart from that, This is my first, session, and maybe you haven't seen my face. Let me um, come to and show my face here. Yeah, just I mean, just okay. I think yeah, yeah. I think hope you can see me. Um, yeah. So it's overall a good session, and I really wanted to share this information for a very long time. Somehow I find some time. I really happy that I did share with you all, and uh, let's focus on the area and the skill set that we want to develop and work on it and get into the right area and start building our career. So there are a lot of opportunities out there, and we will be keep creating the opportunities. So let us stay focused and let's enter into our dream um, domain VLSI. Okay. So yeah, I think you can keep commenting in the below, and if any specific questions, you can always comment in the comment sections, and there'll be more updates, and it just beginning, and so let's stay connected and keep learning and keep cherishing. Okay, so thank you all. It's nice time and nice talk to you all. Yeah, bye.